Greetings, everyone. It's a pleasure to have this interaction with you all. My name is Annu Singh. I am a tech evangelist and an emerging technology enthusiast. I'm an avid learner and I love learning new technologies like RPA, machine learning, AI, blockchain, etc. I have around 17 years in IT and software industry experience now. I'm also a tech blogger, a speaker, and a panelist. Uh, on a personal front, I love long drives. I'm an aspirational biker. I dream to own a Harley Davidson at some point of time in my life. And I really am happy to and excited to look for and looking forward to sharing my thoughts on AI with you all today. So to begin with, the session today would be in four modules. We would look at what is the foundation of AI, what is AI, why is artificial intelligence so important now, what are the core aspects of intelligence, and we will look at the timeline and growth of AI. We would also touch on the main components or the fundamentals of the AI. We would look at what is machine learning, although we will not go into the details of how the software, intelligent softwares are built. This is not going to be a deep dive into a predictive data modeling, nor is it going to be a comprehensive guide to cognitive app development. So we would look at what are the basic terminologies of the AI to help understand the landscape of the AI. Then we would look at some of the important use cases of AI. How is it being used? How is it effective? How it's enriching lives in and around us? And then we would look at some of the new careers that are developing around AI and how can you start on the AI journey if after today's session it excites and interests you. I have used a lot of images in this session, and I have given the source credits, and I would like to give a disclaimer there that the material that I have used is not necessarily my copyright material. I've used it purely for educational purposes. So to get started on what are the foundation of AI, I would like to understand the experience or the knowledge or understanding that our attendees today have of AI. So Lanka, if you could please cue in the polling question. We have 4 polling questions in front of ahead of each of our modules. These are just basic questions, so just to help me understand your understanding of the AI. So we have the poll question on the screen now. If you could please uh, participate. Thank you, Lanka.
You're welcome. So we'll give people a few more seconds. And I think we got most of the attendees' answers. I'll end the poll to read answers and results.
It's interesting to see that 13% thinks that it will be the downfall of humanity, and that is an aspect that I would address towards the last section of the session today, and look at some of the myths and fears around AI. So it's really interesting to have that viewpoint on board. Thank you so much for the inputs. As everybody agrees, I do agree with the first part. The A and B are the correct answers. Let's look at what is AI. Now, today, AI is powering almost various high-tech products in and around us, whether it is the autonomous cars or the self-driving cars, the humanoid, like the Sophie, which was created by Hanson Robotics Hong Kong, or it's the Boston Dynamics that's creating all the bots, high-end defense bots, etc. Or it is the industrial robots that are now advanced enough to create surgeries, suture a great back, In fact, if you look at the Google car Waymo that I have highlighted here, it's already done 1 million miles of kilometers around testing on the roads. Uh, if you look at Apple, Uber, they're also testing their own cars. So AI is today all around us. But if we look at what is AI, there is a general perception in myth that AI is something that has developed in the last decade. But that is not true. The journey of AI started 60 years back. If we AI is the artificial intelligence is a word that was coined by John McCarthy in 1956 in a workshop in Dartmouth College in New Hampshire. He, along with Marvin Minsky and a few others, uh, 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 collaborated to give the basic concepts of the AI and define AI. Marvin Minsky actually in 1956 opened the AI MIT lab. And if you look at the definition, simple definition that John McCarthy proposed was that AI is the science and engineering of making intelligent machines. Right? The goal of these machines should be able to examine their surroundings and make decisions that optimize the chance of accomplishing a specific task in the most efficient way. So to understand, now AI is nothing but teaching the machines to learn, act, and think as humans would. How is that achieved? It is achieved through a set of technologies that allows us to extract knowledge from the data. So it's any kind of system that learns and understands patterns within the data, can identify those patterns, and then reproduce the information, new information, which probably is not possible without the machine or the processing abilities of the machine to do so. Uh, the aim of AI is to create intelligent machines that show human intelligence parameters like the visual perception, ability to see and observe, speech recognition and inference, cognition, decision-making abilities. Now, if we look at John McCarthy's definition of AI in the initial days, he defined human intelligence with 6 aspects. That a human, any machine that is able to mimic human behavior or human intelligence should have these 6 parameters. They should have the capability of natural language processing. They should have a perception. They should have reasoning capability. They should have navigation capabilities and learning capabilities. So if you look at these sub-objectives, then the natural language processing is the ability of the machines to understand, speak, and translate human language. Understand the context in which the communication is being done, understand the words, and infer meaning from the words in the context in which these are being used. If you look at perception, then perception is the ability to perceive the real world object. You should be able to understand and perceive the sound, sight, and touch. If you look at Xbox Kinect, then it perceives the dancer or you through the cameras and infrared, and on the basis of the information that it receives from the camera and the infrared on your proximity to the actual dance step, it scores you, right? Then the third aspect of intelligence is it should be able to reason. There should be a capability to reason out things, like playing games. The machine should be able to interpret and infer the next step of the opponent and reason out the logic for reacting to that situation. It should be able to draw logical inference about mathematical, theoretical, or medicinal diagnosis. Then the next aspect is the navigation. Now, this is the toughest part in any machine to develop, because for a machine to be able to navigate, it should have the capability to plan. It should be able to understand how it will go from place A to B, or it should be able to locate that place. It should be able to judge between the multiple paths that are available and which one is the best for it. It should be able to understand what is safe for it, how to move the objects or obstacles in its path, or navigate the obstacles in its path. It should be able to understand what is an object in real life, what are man, what are people, what is the door, what is the window, what's the wall. So it should be able to understand and interpret these obstacles and learn to navigate them. And last and the most important part is the capability to learn. An intelligent machine is something which, without being fed the program for it, is able to infer from the experience, learn from its experience, represent the knowledge, and interpret the experience for taking the decisions in the complex scenarios. So any machine that has these capabilities would classify as intelligent machine, and AI in simple terms is the capability to build machines that exhibit these six behaviors. Now, how is that achieved? Uh, the AI is actually a multidisciplinary approach. It is not one single subject or one single study that enables AI to mimic human intelligence. A number of subjects, a wide plethora of subjects, are actually referred to create this capability. From computer science and electrical engineering, the software and hardware capability, how AI is implemented in them comes in. uh, AI uses a number of hardwares like sensors, cameras, LiDARs, radars to capture the data. Uh, Software, again, the software rule-based programs that are would be limited in complex situations. So the ability of the programs, algorithms to learn on their own using libraries, using the environmental data that's coming from their sensors, etc., based on the models on which they are built, is what is going to give them the ability to take the right decisions. And on that is formed on the basis of statistical models, and that is where maths and statistics comes into picture. Then one of the key aspects, as we saw in the subcategories or of the intelligence, is the natural language processing, the ability of the machines to interpret the language, understand the context, and understand the behavior of the entity that they're interacting with. And that information or that knowledge is derived from the psychology and linguistic pure subjects. When we are talking about intelligent machines, these are machines that are capable of taking decisions and executing these decisions without human intervention. So when we're talking about self-executing machines, then a key aspect comes in of intelligence and ethical consideration. Like one of our participants said that this can be a doom for the human race. That is where these fears come in, that how do we make sure that the AI is capable of ethical decision making and ethical execution. And for that, we refer to the philosophy as a subject to guide us on the creation of the AI. Now, like I said, that there's a perception that AI is a decade-old phenomenon, but AI started long before. If we look at the journey of AI, the Turing test, Alan Turing is considered as the father of AI actually. He suggested in 1950 that if a machine can trick humans into thinking that it is human, then it is considered as an intelligent machine. In 1955 and 56, John McCarthy coined the term AI, and from there on, it took on. In fact, the first chatbot was created in 1964. 1958 was the first AI language list that was created. But then AI hit a winter, and we would look at the reasons why AI went into a slumber and why it is only in the last decade that we saw an upward trend in AI, and it is now permeating every single aspect of our life. With AI forming the base of Siri, Cortana, these voice virtual assistants, and robots doing surgeries and autonomous vehicles and everything. In fact, it is in 2011 that Watson was capable of defeating and winning $1 million in the game of Jeopardy. In 2017, the AI had advanced enough to actually defeat the world champion in AlphaGo, which is a board game which is like 2,000 years old and one of the toughest in terms of analysis and inference and logical decision making. So let's look at what happened from 1950 to to the last decade. Why did AI hit a slumber? If we look at the AI timeline, then there are a couple of key factors that has resulted in the rise of AI in the last 10 years or so, in the last decade. During the AI, as we looked at, is basically based on algorithms. It's based on computational mathematical inferences and ability to learn on its own using these algorithms. Now, if we're talking about algorithms, these algorithms are based on large amount of data. And initially, in the early days, there was limited computer processing power, there was limited database capacity, there was limited network capability. And all these were factors that inhibited the actual growth of AI. If you look in the last decades now, we have phones, mobile phones. They have grown cheaper, faster, and smaller. There's connectivity to transfer data from the source to various systems. Their connectivity is 4G, 5G, coming over 5G everywhere now. There are all kinds of hardware in the terms of IoT and big data expansion, sensors, cameras, radars, lidars that are able to capture this data and transfer them to the central databases or using end computing or distributed computing. Distributed computing is the ability of the machine where a group of machines can process the data. Each machine would have a subsection of data to process, and then the information can be united and to form the absolute total picture, right? So normally, if there's data which is above 15 GB, 20 GB, then a distributed computing processing is used. And if the data is, you need faster processing in smaller data, then global processing unit, GPUs are used. So these are the factors: the rise of the connectivity, the higher processing capability, the processing powers in terms of the phones and the connectors and the sensors and hardware improving and software improving. That has actually resulted in the spread of AI now. Now let's look at some of the few terms or concepts of AI. AI, like I said, is basically created from or rest on the fundamentals of a lot of mathematical and statistical models and algorithms. It is these algorithms that helps it decide or helps it analyze the data, derive information from this data which is not visible, or detect these patterns and trends which is not visible to the humans in their capacity to process. Now, we will look at the fundamentals of what these basic sciences or basic subjects are that form the foundation of the AI. But before that, I would say to Lanka, if you could pose our second question of the poll, please.
Sure. And I'll switch. Launch polling. And so now you should be able to all see it and you can vote. And I know you're fading at certain points.
I'll be more careful. Thank you, Lanka.
No worries. So we'll give a few more seconds so more people can participate. Okay, 2 seconds. And let's look at the results.
That is correct. Proactive learning is not the way how AI is learned. Thank you so much. So even before we go into machine learning and what is machine learning and what is supervised, unsupervised, or reinforcement learning, let me talk a little bit about what is weak AI. Basically, AI is in today's world is classified as weak or narrow AI, generalized AI, or the super AI. Now, the narrow AI is basically applied to a specific domain. For example, if we're looking at language tutors, virtual assistants, recommendation engines, marketing campaigns, AI-powered web searches, then all these are examples of a weak or narrow AI. They can perform specific tasks, but they do not learn new ones. They will make decisions based on the programmed algorithms and the training data. The next stage of AI is from moving from the narrow AI to the generalized AI. This is the stage where the AI can interact and operate with a wide variety of independent and unrelated tasks. This is the stage where AI can be compared to perform at human level of intelligence. It can teach itself new strategies based on the new problems that it faces and experience that it had with previous data and previous exposure to the old problems. And the third stage of AI is considered as the super AI or the conscious AI. That is where the AI matches the human level consciousness, where the AI is self-aware. But we are a long way to go from that super AI or the human level of consciousness being developed in the AIs. So we are at this point of time more towards generalized AI and narrow AI applications in the industry. And I think the fear that comes in most of the time is because of this concept of the super AI or the AI developing a human consciousness. We will look at it more towards the end of the session, but let's first understand the key fundamentals of the or the key foundation of the AI, which is the machine learning and deep learning. So AI, we saw that AI is basically an approach to make intelligent machines that mimic human behaviors. But its foundation lies in two kind of core concepts. One is the machine learning, and second is the deep learning. Now, machine learning is basically a scientific study of algorithms and statistical models that enables the software model to learn based on its experience rather than being fed explicit instructions or being fed hard-coded programs. It has the capability to rely on the patterns, identify patterns, and draw inferences from these patterns on its own, based on its own experience learning, rather than the like I said, rather than being hard code programming being done. Now, ever since the humans started observing the nature, we have been fascinated by mimicking the real life examples. We observed the birds and we created aircrafts. Similarly, when the research started for AI, there was a keen interest to understand how animal behaves or humans behave in learning new tasks or new behaviors. And that happens through neural networks or brain neural networks, where the information is passed through the connections created through these neural networks. And that concept was mimicked, or that formed the basis of creating these deep learning models where neural networks form the foundation. In today's session, we would not be looking at in detail on deep learning and machine learning. Like Lanka said, that there is another session coming in on 29th of July, which would be looking at machine learning. And in days ahead, probably there would be a session planned for deep learning. But we would still understand the core concepts of machine learning in this session. So Machine learning is basically the ability to learn from the data uh, without being explicitly programmed. Right? Machine learning is a term that was coined in 1959 by Arthur Samuel, and it is, in simple words, it's a technique in which we train a software model using the data. The model learns from the training cases, and then we can use the trained model to make predictions for the new data cases. Now, there are three types of machine learning, which is basically supervised learning, unsupervised learning, and reinforcement learning. Proactive learning is not how AI learns. We'll look at, before I go into classification regression, these are applications of supervised learning, clustering, dimensionality reduction, recommendation, and reward maximization. I don't want to scare you with these words. Let's first look at what is supervised learning and unsupervised learning in very simple terms. Now, supervised learning is basically uh, where if the output is known, then humans are able to label it. Say this is fraud, this is not fraud. This is malware, and this is not a malware. So if the data can be labeled by humans, then in those scenarios, the data can be used, labeled, and used to train the machines, right? So uh, the data is divided into two sections. One is the training data, and second is the testing data. In the using the training data and using the labels that have been put in by humans, the software model is trained. Once it is trained on this training set of the data, then the testing data of set because the output is already known, then you can check the accuracy of the learning of these models and then fine tune them accordingly. But what happens if the data cannot be labeled, if the output is not known? Then in that case, the unsupervised learning comes into picture. Here, the model looks at how close or far a transaction is from its threshold, right? So in simple terms, if we can categorize a data in there is a numerical threshold that we can put in data, then a supervised learning technique can be applied on it. It can predict a category, so it can if we can classify the type of the sock or the on the basis of the color. If you want to classify or divide the ties by the length, then you can, if you can want to predict a number, then you can kind of use regression. Similarly, the data which is not labeled in any way, so that way there you can bring in the unsupervised learning. You can divide the data by similarity. It's called as clustering, where you split up, say, similar clothing into stacks. So you have the tops, you have the blouses, you have the what do you call this thing, the trousers, and so on. If you want to reduce the dimension reduction for dimension reduction or generalization, there's huge amount of data, there's large amount of categories, and you want to kind of reduce those and generalize the data, then making the best outfit from the given clothes, that kind of a decision making, then you go for dimension reduction. Then the third aspect that is generally brought in is association. So what kind of finding the hidden dependency? What kind of data do I often wear together? And where are these? The next question comes is that why am I talking about them? I'm talking about these aspects or these words because these are the basic techniques which are actually used in the implementation of AI that we see all around us. So if we look at the machine learning and look at these three aspects, the supervised learning, the unsupervised learning, and the reinforcement learning. Let me talk about reinforcement learning a little before we look at how these techniques are being implemented in and around us. Reinforcement learning, the focus is on award maximizing behavior. So if a decision making, if it's a positive decision, then it is awarded by certain behaviors and that is reinforced. So uh, if we look at the unsupervised learning and we look at clustering, then various recommender system like Amazon, we buy a product and it says you may like this also. Similarly, Netflix, we see a movie or a drama, a serial on it, and it gives us recommendation based on our understanding. So those are based on clustering kind of, on the clustering technique. Targeted marketing, customer segmentation, these are examples of clustering. Similarly, if you look at the big data visualization, categorization, population by certain, living standards, meaningful, reducing the data to, what do you call this, and compressing the data to certain bigger categories, feature elicitations, then those are used by dimensional reductions. If we look at classification, then image classification, whether this is an object, this is a car or a vehicle, these are people, this is a fruit or a vegetable, that kind of image classification can be done using these classification techniques, identifying fraud detections, customer retention, what kind of customers are repeat customers, what kind of customers tend to leave us early. Those are examples of the techniques for classification. Regression, if we look at regression, then estimating the life expectancy, doing the weathercast, probability of a rain, probability of snow or a drought, uh, population growth predictions in the areas, then those are all examples of regression capability. Now, where are these basically applied? Now, there has been a lot of AI applications in the natural language processing, voice bots, gaming, speech recognition, vision systems, facial recognition, in autonomous vehicles, healthcare. We will, in the next section, now look at what are these applications of AI that we see in and around us and how it is changing life around us. But before we go to the next section, I would request uh, Lanka to give us the next poll question, please.
Sure. We'll launch the third poll. You're welcome to participate, voting which of these is not an application of AI. Let's give 8 more seconds and we'll end the poll. Okay. And let's see results. Can you see results, Annu?
Yes, I can. Thank you. Okay. So, I agree. 56% have predicted it right, that precise disease diagnosis and prescribing treatment independently is not an application of AI. Now, if we look at AI, artificial intelligence, IBM actually defines AI as augmented intelligence, right? The whole concept of AI is not actually to attempt to replace human experts, but rather extend the human capabilities to accomplish tasks that neither humans nor machines can do on their own, right? The idea is to scale the capability of the humans and let machines do the time consuming work and provide the information and the evidence that is required by the subject matter experts to take informed decisions. If we look at the first option where it said take decisions on prescribing medicine, that is something AI still is not doing. It can diagnose a disease, it can give recommendations to the doctors, but it does not actually go ahead and prescribe directly to a patient on the course of action as yet. So let's look at what are the applications of AI around us. AI, like I said, is permeating every single aspect of our life, whether it is from self-driving cars, we have intelligent cars, public transportation, healthcare, medical diagnosis and monitoring, education, evaluation, personalized coaching, personal voice assistants, personal assistants, whether it is in finance, algorithm trading, buying, selling decisions, security monitoring, personal finance monitoring, insecurity, dealing with threats and intelligent threats, etc. I would take use cases in certain areas like healthcare and few industries to see where actually it's being implemented. If we look at AI, according to PwC, PricewaterhouseCoopers, it's a $16 trillion of GDP that will be added between now and 2030 on the basis of AI. Right? This is at a scale that is never been seen before, and it's not just in AI, just in IT industry, right? Its impact is in across the industry, and that is what I would be looking at: healthcare and real estate and cybersecurity. Few of the industries we would be looking at that how individually in these industries it's changing the landscape. Like I started with the example that now we have robot assisted surgeries. We have the virtual nursing assistants that are looking in. I'll tell you a simple example of how AI is making an impact in the healthcare. We have had stethoscopes for ages now. Now the stethoscopes have been turned into digital stethoscope by putting a sensor in the stethoscope. Once you look at this digital stethoscope, the doctor uses it, the heart rates get recorded in these sensors. These sensors can connect to the phones. From the phone, your heartbeat, your heart rate data goes into the applications through Bluetooth or Wi-Fi into these applications, and once this data is digitalized, it can be shared with cardiologists, it can be shared with any of your specialist doctors that could be looking and can assess your previous history with your current parameters and taking the decisions for you. So it is how to extend the current capability of the systems using the AI. That is where the AI is heading. How to add X to the current to take it to the next level. That is where AI in most industries is being used currently. So if you look at healthcare, whether it is helping doctors arrive at more accurate preliminary diagnosis, reading the medical imaging, finding appropriate clinical trials for patients, looking at neonatal, what you call this thing, uh, neonatal diagnosis for the mother and the fetus, looking at clinical trial participation, protecting the fraud in medical industry. Then the virtual nursing assistant for the senior citizens. All these are the examples that you see in healthcare. If you look in cybersecurity, then malware identification, threat detection, ability to change these threats, simple things like whether it is Google, whether it is Yahoo, whether it is Outlook, we are able to kind of filter spams and hams. That's a pretty basic example of the ability of AI to kind of start from there and then review the data at the enterprise level for threat detection, for categorizing these attacks, adapting to the changing threats, taking the predictive maintenance for our systems, better spam and phishing detection. These are some of the examples that we see where AI would be implemented in the cybersecurity. If we look at AI in the commerce, there's a lot of emphasis on bringing voice into voice-enabled commerce now. If we look at some of the data that is on this infographic, it says that 40 billion voice-based shopping potential in US by 2022. So a lot of organizations and companies are focusing on this conversational commerce where you can interact with the customers using the NLP, the natural language processing capabilities of their voice bots and virtual assistants, and deep provide deep sales and customer service and engage the customers. Ability to kind of customize the AI enabled payments. So there is China, which is actually trying where you don't need a credit card anymore. You don't need phone payments. You don't need anything. Your face is used as your, as your payment method. So from the facial recognition, the payments are automatically, what do you call this thing, approved, right? Classifying and tagging information, then improving the customer profile based on that, then recommending products and actually focusing on deepening the wallet of current existing customers. These are all the examples where AI is being used. If we look at finance, then monitoring our investment, detecting fraudulent transactions, identifying credit card fraud, preventing financial crimes, uh, chatbots looking and monitoring and advising us on investments, algorithm trading, knowing when to buy, when to sell, guiding us in those kind of decisions. Then in sales, there's a lot of focus on drones for delivery. Also, robots. Even before we see these robots doing our kitchen work or cleaning our doing our household work, there's a large probability that actually these robots would be, you would see them in retail, shelf, putting the stocking them on the stocking stuff on the higher shelves or bigger, looking at high assisting the retail employees lifting heavy products, using them in higher machineries, difficult scenarios or difficult terrains. That kind of scenario, you would see the machines taking over more, or assisting the employees more and more. So government defense intelligence, whether it is the drones or the self-flying vehicles, for surveillance, whether it is for rescue and research capabilities, whether it is for analytics based on various country data in terms of banking and various uh, government spendings on their plans and programs for governance. All these are scenarios where AI is now taking over. If you look at, like I said, that PricewaterhouseCoopers says there's 16 trillion of GDP that is going to be added between now and 2030 on the basis of AI. If we look at the top three areas where AI is taking over, by expected to take over the most by 2025, is image recognition, classification and tagging, algorithm trading and strategy, and healthcare, ability to process and the patient data that is ever growing. And currently most of this data is lying unprocessed. If you look at the medical advancement, there are thousands and thousands of journals that are published every month, and the ability to kind of go through, read these journals and derive actual decisions out of these journals for better information and decision making for the doctors, whether it's not only medical, even in legal area, in the legal industry. The same goes where the documentation is important, and so much of content is in documentation. So these bots have that capability to process these documents at a much faster pace than any human alone can do. So detection, classification, these are few examples where you would see AI start supporting the humans. So this was, so far we have covered what is AI. We looked at what is narrow AI, generic AI, and super AI. Then we went and understood what is machine learning. We looked at supervised, unsupervised learning, reinforcement learning. Then we touched on some of the use cases of AI in different industries. Now we're going to go towards the most important aspect that hits each one of us, including you and me, and that is how will AI impact the job market and our future and careers. So, but before I go to that section, I would request Lanka to give us the fourth uh, question.
Okay, so that is the last poll, I believe. And
Yes.
we have 10 more minutes.
Yeah, so I would be quick to wrap it.
And please take your vote on what is the role that philosophy plays in AI. I'll give a few more seconds for anyone who still would like to participate. Okay, so let's see the results.
Okay, interesting. Philosophy is these are interesting results. Determine viable learning model, measure performance. That's more to do with mathematics and statistical and algorithm development in software or computer sciences. It is more intelligence and understanding of intelligence and application of intelligence and ethical consideration, which is where we refer to philosophy to guide the AI implementation. So C is more correct answer in this case.
Okay, and Annu, I still ask you to speak closer to your microphone, please.
Thank you so much
No.
for reminding. Okay, so I'll quickly, I know I want to leave some time for the questions for the next, before we close. And I know Lanka has given us 10 minutes time here. So reminder. So I'll just quickly go on the next section. If we look at AI and careers, one of the biggest fear is that AI will take our jobs. It is not a baseless fear. If we talk about, there was a report that came in from the World Economic Forum, and it said that by 2022, about 75 million jobs would be lost to machines and algorithms. But this report further said that 133 million new roles will emerge due to the rapid evolution of machines and AI in the workplace. That actually translates into 58 million net new jobs that will be created in the next few years. So if you look at this map, it says that which are the areas where you would see that the AI will actually improve the jobs and where AI would take away the jobs. So if you look at areas where it is manual intervention, where it is rule based, that can be programmed easily, then those are the areas where AI is expected to actually take over our jobs. But where the human element is going to be higher, whether it is healthcare, social work, education, communication, the human touch, it is going to be difficult for AI even yet in the next few years to kind of replace humans completely. And that is where you would see more and more of these works grow. So if you are entering the workforce or getting skilled in AI, then this represents a good opportunity for a career. Even for those who are in the workforce, getting skilled in AI, reskilling and upskilling with future-oriented skills, such as AI, is more relevant now than ever before. At the organization level, the need is now felt that there needs to be a change in the skill set. The current skills of the workers need to be augmented. And at the personal level, we have all started feeling that AI will do some of the current tasks that each one of us have been doing in our job, which is correct. But having said that, we would have to augment our skills so that we learn to cohabit and work along these collaboration bots that are going to make our life easier. So, how do I move towards a career in AI? Currently, there are plenty of options that are available in terms of getting you started in AI at different stages, whether it is beginners, intermediate, expert level. So you have all these open source platforms like Coursera, edX, Udacity that offers these courses. There are a lot of languages that are around like Python, R, Java, Prolog, Lisp that kind of give you a head start to learning these in terms of building these statistical models, graphical models, depending upon which kind of field you are working or interested in, and what will be the application that you want to implement or work towards. That is what will help you kind of take the decisions on these what kind of language to learn. But on a simple form, Python and R are the most used, that are currently most widely used, that have cross industry applications. There are multiple tools, whether it is Microsoft Cognitive Toolkit, Azure Platform, Apache frameworks, Kit, which TensorFlow, which actually make your life easier in terms of getting started on these AI frameworks. There is also the Watson API, which actually takes away all this basic work from you. And once you learn to use these APIs, you can quickly implement. It gives you a head start in implementing your AI solutions. The kind of skill set, you would have to look at 360-degree skill sets in developing your skills towards moving towards AI. So you would have to work on learning a bit of machine learning, a bit of algorithms, semantics, programming, a basic programming language, uh, basic NLP. There's a lot of work being done by these key organizations. These are just a few, and these are not every and all of it, but I've mentioned a few here. Like Google is investing a lot in DeepMind, IBM in Watson, Microsoft Research, Baidu, Google, Facebook, OpenAI platforms, and Apple, that have a lot of these trainings available, and applications and examples and use cases of where the AI is going to head, and take, what you can and how you can start learning. So this was AI in short from my end. I am now, thank you so much for your patience, and open to questions now. Thank you.